Welcome, everybody, to Weekly Quantum World Detangled, Season 5, Episode 2. We are joined by my friend and sponsor, Denis from INQ.
Hi, everyone. Happy to see you this week. Very excited. We have a great visitor today, and I'm looking forward to, I think this is one of our first or maybe one of our few discussions on quantum cryptography. So, Deniss, you want to start off and introduce yourself?
Sure. Denis Mandich. I'm the CTO of Crypt. We're a post-quantum cryptography company. My background is a physicist and a lot of government service in the intelligence community working on quantum secure systems.
We're excited to have you, Denis, and I had the pleasure to visit you in your office, World Trade Center, 86th floor, 83rd floor, last week, which has a gorgeous view that is hard to see today, unfortunately. One of the first things that stood out, you have this collection of beautiful old ciphers, and I posted one of those pictures on my LinkedIn. Tell us a little bit about that. How did you guys decide to start that collection? Where did you get them from, and what do they mean to you?
Yeah, the history of crypto systems and encryption is very long, and the ones that we've been fortunate to be able to collect and acquire here are very relevant. Certainly during the Cold War, a lot of us had worked in the intelligence community. We know how important good cryptography was and how important it is today for the privacy of the individual. And so we felt like where we started in the history of it to where we are today, when all this stuff is just virtual infrastructures and data centers, you don't actually have a crypto machine anymore, that was relevant to have that to show off to people. So getting them is very hard. And as I think I pointed out, the first one in our group there is among the rarest. It's a Soviet era fialka, which were destroyed after the Cold War and burned in the bottom of these big piles, and only a few survived. And then, of course, the Enigma, the Swiss version, the NEMA.
It was really amazing to see. If any of our listeners can score an invitation to the Crypt offices, be sure to accept it. We mentioned intelligence, and after your studies in string physics, that's been your background and career for about 20 years, I believe. Tell us as much as you can. Where were you born? Where were you raised? How did you get into intelligence? And what did you do in intelligence?
Oh, gosh, that's an even longer story. You know, I'm a refugee here from the Cold War. My family got political asylum in the 1970s. I was born and raised in Zagreb, Croatia, with the former Yugoslavia. And at the time, you couldn't leave the country with your whole family. You had to leave anchors behind. So my family worked it out so that we left different borders and met up in Austria, got political asylum in the U.S. and became, homeless refugees here in the United States. And, typical American dream stuff. And, fast forward years, studied physics, string theory. Is what I did my undergraduate and graduate work in. I started my career shortly after that in the intelligence community, working on high security systems, nuclear weapons technology, things like that. And, the typical thing, the CIA and all these agencies are full of foreigners because we speak all the really hard languages that are hard for Americans to learn. And, I have to also know nuclear physics technology as well, and combine that to, a couple of decades learning how these systems work and then bringing some of that knowledge into the commercial sector. We strongly believe in the intelligence community that privacy and strong communications are national security priority for our economic security, for the individual. So we wanted to bring the things that we enjoyed there, which are, quantum secure and quantum resistant systems, to the private sector and make that really easy and accessible to commercial and private users.
And I'm not going to ask you about any of your secrets, but let me ask you this. How worried would you say should a large company, in the Western world be about security and privacy? And what would you recommend they do?
Yeah, it's in our collective interest that we all have very good cybersecurity. Everything from the Colonial Pipeline fiasco that we saw a few weeks ago to the amount of personally identifiable information that we have coming out of these big companies that hold a lot of that data that was previously the domain of the U.S. government only, and how useful that is to operationalize it, whether it's secrets to pharmaceuticals or software or any of these systems that will eventually be operationalized in other countries and monetized and putting a lot of U.S. companies out of business. So it's a national security priority to get this right. And one of the biggest transitions that we've seen in recent memory is this move from pre-quantum to post-quantum secure systems. We don't really know when these cryptographically relevant quantum computers will come online or break existing infrastructure, but we do know that a lot of that data has been harvested for decades. This goes back to decades and decades of the Cold War with something called the Venona Project, and that stuff is going to be useful for a really long time. So the time is now to really transition to something that's durable for the long term, and it's super important for all of us. I want my kids to, work for a big U.S. corporation, not end up having to work for Huawei or somebody else.
And how about at an individual level? I don't think that I have any terrible secrets, but my documents, my emails, my health data. Do you personally take specific steps that others might not take to safeguard your data, and what would you tell the world?
Oh, absolutely. That's a common theme that I individually do not have secrets or anything that I really care about, but all the things about your day-to-day life are really important. And you can look to China to see how that is done publicly today. It was done privately by intelligence agencies in the past, but they assign a social score to everything that you do every day. The things that you talk about, the things that you search, the people that you're connected with, your social graph, how that fits in with everyone else on the planet, your machine graph, how is your laptop and messaging services that you use connected to everybody else. All those things are very important, and information traditionally, going back during the Cold War, was never used for good first. It was used for nefarious purposes. It was not making society better. It was actually used to categorize you. In the future, they'll decide what your insurance rates are. Your kids get into college because they were in Instagram pictures drinking beers when they were 12. And it's correct that is a risk factor for not doing well at Harvard. All these things are valid, but people change, and I don't want, some company being able to data mine me and assign a social score or anything else for anything that I'm doing in the future. That should be private. Those are things that we should hold dear, especially about our relationships. So we've actually built tools to make it easy for you to do that. It's going to become easier in the future, so that we, Crypt as a cryptographic service and utility, that's not our model is to data mine you. It's to go out there and make the tools available to you at a cost to make it private, so that we go back to how it used to be, the order that we had before the internet came online, where we could have a private conversation in our homes or among ourselves without somebody data mining it and trying to monetize it.
And Denise will dig into your tools and solutions in a second. One last question from me. Obviously, in consequence, you're a very private person. There's little information to be found about you online. I noticed one interesting post, I think it was on LinkedIn a few months ago, where somebody had shared a quantum ecosystem map of about 500 companies divvied up, and you shared and commented that post, saying it might benefit from some additional dimensions, which would ultimately reveal hidden entanglements. What did you mean by that?
I love the quantum ecosystem growing and getting bigger. There's so many amazing things that will come when we have large enough quantum computers for drug discovery, for making all kinds of efficient systems that are discussed in public already. But also on the quantum security side, this is something we all need collectively. It's best for everyone to have it. And the more companies interact, the more we leverage each other's tools, the more we become a cohesive entity, even if we're competitors, it's better for everybody. So quantum everything improves the lives of other people. Unfortunately, right now, quantum computers and the things that can break our security are moving way faster than we're going to be able to catch up with the quantum security to protect ourselves.
All right, André, I'm cutting you off. It's my turn. Denis, it's a pleasure to meet you. So it's funny, I've been watching your company because for some reason I'm on your email list, and I'm not complaining. I really enjoy the emails, and I wanted to start to congratulate you that you're offering quantum entropy as a service, where you're offering access to quantum random numbers. And so I just wanted you to give another overview of your company and some of the offerings to people, because I really love what you're doing. And I think more people need to learn about it.
Thank you, Denise. I really, coming from IonQ, that's a huge compliment. We'd love to follow in your footsteps and a lot of what you've done. You're far ahead of us. But with Entropy as a service, that gives you the ability to generate truly random numbers, which can't be done with normal computer electronics. Noise sources are typically at best chaotic. Chaotic systems are easily modeled by simple differential equations we all learned in college. And that leads to patterns where I can now guess your keys. And the preferred method for any hacker that's sophisticated or any government agency is not brute forcing your security or trying to break your cryptographic algorithms with supercomputers. That's costly, that's time consuming, it's not efficient. I'll just guess your keys. If I know that you have a poor random number generator, which most computers have, or mobile phones that I can model and I can guess your keys, then I can just break everything you've ever done very quickly and efficiently. So the foundational piece for all cryptography, for all security, is the ability to generate true random numbers. We only know one way to do that. That's by performing a quantum measurement on something. The way we've done that is by leveraging research at big national labs around the world, two in the US that I'm sure you've heard of, Los Alamos National Lab and Oak Ridge National Lab, where this foundational research was done on how do I get entropy from a quantum measurement and turn that into random numbers for cryptography. We've taken those laptop experiments and reduced them down to something that fits inside of a server appliance that you can now use through simple APIs over the internet. You don't have to own this physics experiment, which sits in a rack in a data center, but you can still use it for all your classical crypto systems as well as your post-quantum systems.
Really great offering, really great. How long has it been around?
We've been around since 2017. A lot of this work had to be done in stealth. We needed the background on us. Everything we do is published in the open source peer-reviewed journal. Everything is in a public patent. We do not believe in any black boxes, no security by obscurity. So everything that you see in the journal articles that we have, a couple dozen of them at this point, or in the patents that we filed, is actually what is in our appliances. That's what's in our software. And so you saw what happened with WhatsApp and so on today. Now it's finally known that they can actually data mine your encrypted messages, your content. We built an application that does away with all of that, since our model is not turning people and their data into a product. It is simply the cryptographic security layer. So we built an app that builds a single point-to-point black tunnel that is truly end-to-end encrypted, meaning we encrypt even with all the information that we have about who the users are. You're not anonymous. We cannot decrypt your messages, either flight or at the endpoints. So building software like that that's never been done before, incorporating quantum entropy sources as a service that feeds into the key for all that software, that took a lot of time to get that right. There's a lot of things that you can use off the shelf from GitHub and open source. That's just not trustworthy. It's polluted with software that was developed at the world's intelligence agency and donated to all these organizations. So supply chain is a huge issue. All of our hardware is manufactured by us, getting those relationships up and running, and then all the software and researcher relationships in the US and abroad, where we control the full supply chain.
This is amazing. One of the things is there's a lot of quantum encryption solutions out there. How do you differentiate? I hear a lot of customers expressing confusion. How do you differentiate crypt?
Yeah, unfortunately, there's a lot of snake oil with people saying that things are quantum this, quantum that. Now it's the buzzwords that gets SEO attention from all the search engines. We differentiate crypt by two means. One is there are standards-based compliance issues that will come from NIST, where you have to use certain algorithms. If you're HIPAA compliant or in the financial industry, we support all of those with our own implementation. I'm mentioning the messaging software that we built. There are no other pieces that were made in China, for example. We made everything in there. It only does one thing. It's not a Swiss Army knife. And then on top of that, we add this extra security layer, which allows you to go for something that's quantum safe or quantum resistant to fully quantum secure, which is tantamount to having a one-time pad encryption system, which is traditionally used for the most sensitive information during the Cold War. It's how the red line between the Kremlin and the White House worked for decades. You can transmit it in the open, and it can never be decrypted, not even in principle, unlike all these other systems, which we only, it's like fairy dust. We believe that they're secure against quantum computers, but there's no proof of that. This other type of system, it's absolutely proven back to the 1940s.
So I think that's a really great comment, is that the system is proven. I think there's a lot of claims out there that aren't really proven and aren't really backed up with true research. So I think that's wonderful. When you look at corporate customers, what stance should a corporation take on quantum security? When should they start investigating, adopting? How should they look at this as a problem?
The transition, if we look back to public key infrastructure that was started in the 90s, took 2 decades to get in place and to get it done, and it's not even done today. So it will not take less than 5 years for a big enterprise to transition. Many of their systems cannot support the massive key sizes, for example, in post-quantum cryptography. They don't have the mathematical coprocessors and the other things that are required to do these calculations efficiently. So those systems will just break and have to be replaced. One of the things that are discussed in this circle is that, cryptographers are going to have a job for at least the next 10 years, because this is going to take a long time. It will be very painful for a lot of companies. But if they don't start now, they will not understand the challenges that lie ahead. For example, if we have, we call it the Q2K moment, like the Y2K moment, the day when it's publicly revealed that big enough quantum computers can break all of your key infrastructure. Everyone can't just transition that day to new algorithms. They can't just install new software. That takes a really long time. There are interoperability questions. There's a lot of things that go into that. So what we advocate for now is crypto agility. Start transitioning to something where we can swap these algorithms out if we have to. We find out there's a flaw in them, there's an implementation error. Make it very easy to transition to something that's even stronger, that doesn't even exist today. It might be invented 2 years from now. So that's the important thing. Crypto agility, start now. It's going to take a long time.
Now, in the past, when I've talked to customers about it, they say that they're waiting on NIST for standards. What's your point of view on that? And can you tell us a little bit more about the progress NIST is making?
Sure. The third conference just happened a little over 2 months ago. The first standards will be approved starting next year, and that'll be completed within 18 months or 2 years or so. So if you're in a compliance industry, you will start having to do that process right away, but everyone should, even if it's not a compliance requirement. Those older algorithms will be sunset. There'll be a time frame for that. Let's say it's 5 years. And then the new algorithms will have to have been replaced, including all the software that you're using with them by then. So we expect that this last round will include some of the alternates, which are the stronger, least performant, but they have the highest security, will get approved. we advocate for those. In fact, we have implemented one that's being held in reserve only because it's network crushing. It uses up massive CPU resources. Certainly, battery power for something like this, it's inefficient. But we put it together because for some applications, executive communications, the secret sauce of your company, all those things need to be ultra secure. It may not be sharing cat videos, but you have to start.
That's amazing, Deniss. It's been a pleasure to talk to you and learn about Crypt. Keep the emails coming. And I really do think everybody should go out and check out their website and learn a little bit more about quantum cryptography. So, André, back to you.
Thank you, Denise. Dennis, let's wrap up with our Marcel Bruce, James Lipton weekly Quantum World Detangled rapid fire quiz. 6 questions. And your challenge will be to give 6 one-word or one-sentence answers. So if you're ready, let's get started.
Let's do it.
Dennis, who is your favorite scientist?
Tesla.
I have a painting of him in my living room. Love him. Who is your favorite entrepreneur?
Thiel.
Thiel.
Peter Thiel.
Yep. PayPal. What is the quality that you desire most in an entrepreneur and or a scientist if it's different?
Truly thinking outside the box and being a risk taker, put everything on the line.
What is it that you appreciate most about working in quantum technology?
It's at the cutting edge of science, and that's what drives me every day and everyone that works here.
Other than what Crypt is doing, what might be your favorite quantum tech application?
Quantum computing, for sure. We love it, and we can't wait to see more of it.
What is your quantum dream?
To have access to my own quantum computer and use Crypt every day, technology every day, so that no more of these big companies are data mining me and my family.
What is your quantum nightmare?
That won't happen fast enough, and we'll have massive amounts of quantum computers everywhere before we have this new quantum security deployed.
And you just answered it, but we'll take another run at it. Imagine you wake up to the first universal fault-tolerant quantum computer in your living room tomorrow. It's the only one in the world. You can't use it yourself. Who do you give it to?
I give it to NSA with the caveat it can only be used against terrorists and pedophiles.
That is a big caveat, but we'll take it. And I'll be watching some spy movies tonight. Really a fascinating talk and interesting things that you're doing. Musca law by Professor Musca is this concept that the shelf life of data and the time of implementation of a quantum safe solution probably at this point for many outpaces the window that we have before a quantum computer might be able to do some damage. Entropy as a service, true random numbers, is a quick and easy solution. We need to go fast. Thank you so much, Dennis. Thank you for sharing your ciphers and that little exhibition with me as well. This concludes Season 5, Episode 2 of the Weekly Quantum World Detangled. You are now detangled.